This next one is also asking me for the inverse, except this time I have an equation, and really this equation says y equals 2/5 x plus 3. And if I want the inverse, just like I did before, I switched the x and the y. So instead of y equals, it's going to be x equals. Instead of 2/5 x, it's going to be 2/5 y plus 3. And essentially, this is the inverse, but typically my equations are solved for y, so that's what I'm going to do. I'm going to subtract the 3 from each side. So I get x minus 3 equals 2/5 y. And then from here, you could multiply each side by the reciprocal by 5/2. And that makes this a little bit shorter, but I'll do it in 2 steps. To get rid of the fraction, I can multiply by a 5. And what happens is like 5/1, these 5's cancel. So that leaves me with a 2y. Over here, I have to distribute that 5, so that's a 5x minus 15. And now the last thing I want to do is divide each side by the 2. And I've got 2 options here. Instead of leaving this as a y, I'm going to change it back to function notation. And I can leave this as a 5x minus 15 over 2. That's perfectly acceptable. Or I can rewrite this as 5/2 x minus 15/2. All right, those are my 2 options. But again, make sure it's just written back in my function notation. So either one of these would be acceptable. Okay? For the next one, if I want to decide if these are inverse, I can use my composition tests, which means I'm just going to do f of g of x. And then if that works out, I'll do g of f of x. And what I'm looking for here, I'm looking for each of these compositions to just equal an x. So I've got f of g of x, which is the negative 2x plus 5. And now whatever's in these parentheses, f of x was a 1/2 x minus 5. But instead of x, I plug in whatever's in the parentheses, which is the 2x minus 5. And now I just simplify this. That's going to give me a negative 1x minus 2.5. And then I combine like terms. That's going to give me a negative x. Sorry, this was a plus 5. So that's a plus 2.5. So that's a negative x minus 2.5. And you notice I didn't just get an x here. So I don't even need to bother doing the second composition, part of my composition test. The answer here is no, these are not inverses. Okay, if they are inverses, I'll get an x each time. For the next one, I'm just multiplying these, so I have to use my distributive property. So I'm going to distribute the 2x. And when I do that, it's going to give me a 2x cubed plus 4x squared minus 8x. And then I have to distribute the 1, which is going to give me a plus x squared plus 2x minus 4. And now I combine like terms. The squareds are like terms. The x's are like terms. So I get a 2x cubed plus 5x squared minus 6x minus 4. And that's it. Okay? In number 31, I just have to remember that squaring something like this, a 4x plus 5 squared, means I have to do 4x plus 5 times 4x plus 5. And now I have to distribute or FOIL. Okay, so I distribute the 4x, that's a 16x squared plus 20x. I distribute the 5, that's going to give me a plus 20x plus 25. And now I combine the like terms, the 20x and the 20x, so I get a 16x squared plus 40x plus 25. And that's it. For the next one, I want to divide these, and I could do long division here, but remember, anytime I'm dividing by a binomial of the first degree with a leading coefficient of 1, I can use synthetic division. So I'm going to take the opposite of this guy right here and put it in my box. So I put a negative 3 in my little half box. And now for the thing that's being divided, I'm going to write down the coefficients in descending order. And you'll notice here that I'm missing a term in descending order. So we want to think of it this way, as an x cubed plus a 0x squared, because that's the one I'm missing, then a minus 10x, and a plus 7. So I have to put a 0 in for this missing term when I write down the coefficient. So it's 1, 0, negative 10, and a positive 7. Now I bring down the first coefficient, the 1, and I multiply. I take what's in the box times what's below the line. So negative 3 times 1 is a negative 3, and then I add straight down as a negative 3. Then I multiply negative 3 times negative 3 is a positive 9, and I add straight down, and that's a negative 1. And then I multiply negative 3 times negative 1 is a positive 3, and I add straight down, and that's a 10. And this is where I break out my secret decoder ring. I started with an x cubed and divided by an x to the first, which means now I'm going to have an x squared. So this is a 1x squared minus a 3x minus 1. And then this is my remainder, so I put a plus sign, and I put the 10 over the thing I was dividing by, which is the x plus 3. Okay? The last problem here, we want to find each value and graph this thing. So for the vertex, when I start with the vertex, remember the vertex, I have to do the opposite of b over 2a. So for this one, the b value is a negative 2. Opposite of b is a 2 over 2 times a, which is 1. So that's going to give me a 2 over 2, which is 1. And that's just the x value for the vertex. I still need to go back and find the y value, so I know it's 1 comma something. To find the y value for the vertex, I just have to plug the x value back in. So I'm going to do x squared minus 2x minus 8. But I'm going to plug the 1 in for x to see what y equals. So I plug the 1 in. So it's going to give me a 1 minus 2 minus 8, which is a negative 1 minus 8, which is a negative 9. So my vertex ended up being 1, negative 9. I get the x value and the y value. The axis of symmetry is always x equals because it's the equation of a vertical line. And it's always got to go through the vertex, so it's x equals the x value from the vertex, which is a 1. The y-intercept, remember for the y-intercept I would plug a 0 in for x, and if I plugged zeros in here, I would obviously end up with a negative 8. Remember the shortcut that when I'm in standard form, the y-intercept is always the constant term, which is the negative 8. The x-intercept, before I move on from that, again, I could write this as a 0, negative 8, just to clarify. The x-intercept is when y equals 0. So in other words, I have the equation x squared minus 2x minus 8 equals y, but I'm going to make y a 0. Well, now I'm just solving this problem. Okay, I'm solving for x, so I build a bridge. Gives me a negative 8. The two numbers that multiply to negative 8 but add to negative 2 are negative 4 and a positive 2. And I can use my shortcut on this one. It's an x minus 4 and an x plus 2. And now I set each factor equal to 0, so I do the x minus 4 equals 0. I do the x plus 2 equals 0, and I solve each. For this first one, I add the 4 to each side. So I find out that x equals 4. For this one, I subtract the 2 from each side. So I find out that x equals a negative 2. And those are my two x-intercepts, and I can write them that way. Or I can express them as ordered pairs. It's 4, 0, and a negative 2, 0. And then the last thing I need to decide before I graph this thing is whether it's a maximum or a minimum. Since I have an a value of 1, and that's a positive number, it means this parabola is going to open up, which means it's going to be a happy parabola, which means my vertex is at the bottom. Okay, so my vertex is going to be a minimum value because my parabola is opening up. And now I can graph this thing. And just looking at the values that I have, I'm going to scale my graph by 2s. So now I'm going to graph each of these. So 1, negative 9. It's going to be right here. The axis of symmetry at x equals 1 is going to be right here. Again, that is the equation of a vertical line, and I always express it as a dotted line. The y-intercept at 0, negative 8. It's right here, and I can reflect that over the x-axis, or sorry, the axis of symmetry. And then the x-intercept is a 4, 0, which is right here, and a negative 2, 0, which is right here. And those are reflections of one another. And that gives me plenty of information to graph this parabola. So it looks like that. Okay, that's all there is to it. And good luck on your midterm.